Welcome to another video session on Mat 302, still on linear mapping. So in this case now, in this lesson, we need to consider another question entirely which is similar to the previous one that we've done. So looking at this question here, we also have a linear mapping that is defined by a linear mapping phi. Let's say we have linear map phi, such that we actually have a three-dimensional vector space R3 to another two-dimensional vector space R2. So let this be the projection defined by this expression here. So we have our x, y, z to be equals to just x comma y. So I think we don't have any issue here. Unlike the other one that was x, this one was x plus y plus z. Why this one was y plus z for the previous example. But in this case here, we have just x comma y. So I think this should be very, very fast to solve, and I don't think this should give us any issue to substitute when it comes to substitution. So now what do we need to find? We already have our linear map phi as x comma y, right? That means the image of this simply implies R3 to R2. Do you understand that? That I'm going to have a 3 by 3 matrix here against 2 by 2 matrix. Is that clear? So now we want to look for a matrix A, and I told you that if you want to look for a matrix A, you used to consider standard basis. So if you want to look for the other matrix, now the matrix B, I don't want to use A again. Sorry, that means I have to look for other alternatives. I think that's why they use B. But for the sake of the standard basis we'll be using, I will just advise you to just change this B to A prime. You can actually state it in your solution. Let matrix B represent matrix A prime. Okay, so that you know that your B has already changed to A prime. So you follow the same steps. You are using the same step I used there. Where's the question? Okay, find A prime. So A prime will be given a basis. But for ordinary A, you will not be given the basis. It's just you have to make use of the standard basis. Nobody will give you that. So now looking at this, I can easily state the correct answer to matrix A without using standard basis, just like the way I did it last time. So let's quickly work on the solution. Now looking at this clearly now, if I want to find matrix A, it's very direct. Matrix A is just that, okay, I want to find matrix A. I'll just come here and write, okay, this is the linear map, this is the linear map, this is the linear mapping defined by x comma y. So x comma y is in row form, so to I'll turn it to a colon matrix. That is x here, then y here. Similarly with what I've done. I did think this thing was, let's say, x plus 4y now, and this one is, let's say, 3y plus z. That means the matrix now will now be, I'll write x plus 4y. I'll expect it's in column form, 3y plus z, and that's all. So here in this case now, I notice that I have x, y, z. So that means I need the coefficient. X is here, the coefficient of x is 1, but y is missing in this first row, 0, and at the same time, because there is z here, z is also missing, I will have 0. So in this case now, for the second row, x is missing, I'll put 0. Y has a coefficient of 1, while z is missing. Adp this z is not here now. Adp is x comma y equals to 2x comma. So that means I don't need to include these two zeros that are here, since the image itself is not having z. It does not have z. So, but since I just have x and y, the coefficient of x here is 1, the remaining one is 0. So like this is what I will just have as my matrix A. So how do we come about? How are we going to get this? This is just final answer. I've gotten this straight up. Very easy. But if you do this in the exam, or you will not get your full mark, because they ask you to find the matrix A with respect to the standard basis of R2 and R3 respectively. So what is the standard basis of R2? I've explained that. The standard basis of R2, we always represent it as, okay, we always represent it as a 2 by 2 matrix, okay, and that will be 1 1 0 0. The standard basis for R2, the standard basis for R2, whereby this is my what, F1, this is my what, F2, okay. I think I use this one represent my E, right? This E is for, let's say we are using E for the two-dimensional vector spaces, and we used to use our capital B for our 3 by 3 for our three-dimensional vector spaces. Do you understand that logic? That's why I said I should go and change. That's why I said you should change this matrix B to A prime, so that you not get it confused. Okay. So then this one is our E1, this is our E2, why this one is our E3. So I believe you still remember our standard basis. So this is what you are going to use to solve this question. And then I gave you a general formula then, if you remember. The template that we need to follow is that, okay, you need to write the definition out first. The linear map given to us is being projected to just x and y only. So the formula now says that we should follow this. I said you should start with, okay, now let's check. The image here is R3, okay. Let's say, okay, R3, we have a three-dimensional, the three-dimensional vector space against a two-dimensional vector space. So that means I'm expected to have this one of 3 by 3 image. Since I'm using the, this I want to use, this I want to find the matrix A with respect to the standard basis. So I will consider the 3 by 3 in this place. So I will use E1 here. Remember that this was E1 I used, while this place I use E2, and then the last part I'll use what? E3, right? So the formula now will now be equal to x will be here. Then inside this bracket, since this is the standard basis for a three-dimensional vector spaces, but in this case I'm going to use the standard basis for a two-dimensional vector spaces, and that is f1 and f2. So this one will be f1 plus y, this one will be f2. Recall that I said this is x1, y1, x2, y2, x3, y3, while this remain as f1 all through, okay, while this one remain as f2 all through. Do you understand that logic? Now looking at this now, what is my, so this is for the first stage, Abi. I'm trying to manage the space. So I have my phi of E1. What's my E1? Trivially, E1 is just, let's check this out. Okay, our E1 now, this E1 here, see it, where is it? E1 is for 3 by 3, for a three-dimensional vector space. See my E1 here. E1 is already 1, comma 0, comma 0, and then what's my E2? 0, 1, 0. What's my E3? 0, 0, 1 in that case. So what is the definition? It's defined by what? It's defined, it's projected to xy. What's my x? If I x here is 1, y here is 0, and z is nothing. Okay, that means, okay, I need to write out my x1 first. Let me zoom it out. Let me zoom in back. Okay, now that we have this now, this is what we want to do. Just check this out. Okay, it's fine like this. So I have to clean this. I wanted to clean this before. What's wrong? Sorry for that. I'm coming. Okay. Now we have phi of, here x is 1, y is 0, z is 0. But for the projected expression that we have here, we only have x comma y. So what's my x? Why am I doing the same mistake? I want to write x1 first. So let me just write x1. That's this is x1. This x1 that is here first. I don't know why I'm making a mistake on that. This x1, then I'll open a bracket. This f1 now, this f1 that is here is for 0. Where is it, sir? This f1 is for 1, 0. But before I do that, before I go straight to what I want, this is what I wanted to do. I think I can recall now. This is what I want to do. My x is 1, my y is 0. Then substitute it here. That will give us what? X is 1, y is 0. Just like that. Okay. In this case now, my x is 0, my y is 1, z is nothing. Yeah, there's, I didn't mean there's x plus z now. I mean there's x plus, let's say there's x plus y here. That will be 1 plus 0 is to still give us 1. So you don't have to be confused of this x comma y. You're only substituting the results. Okay. For this second line now, my x is 0, my y is 1, my z is 0. Since x z does not appear here at all, I only have x comma y. Then my x is already 0, my y is already 1. So that's the definition given to us. And for as for this one, we have x is 0, y is 0, z is 1. So x is 0, y is 0, but we don't have any z in this expression. So this is what we have. So this is what I wanted to do. Okay. So this is just like, okay, the phi of E1 is equal to this. And phi of E1 is equivalent to this x1 of f1. So what's f1? 1 comma 0. See it here. Then plus So it was F1, yeah. And what is F2? F2 is 0, comma 1. So you do the same thing for this one too. X2, this one remain the same. So will be X3 and this remain the same. This remain the same. Y3 and this also remain the same. So if you look at this clearly now, I must get this result too for my A. You know that any result I have here, according to the way it is being arranged here, is my A transpose. So I will now find the transpose of it again to get this matrix. So let's confirm. We have already explained to you how to find. Remember that I've explained to you guys how to find x1 and x2, how to find x1 and y1. That is, this will multiply this. This will multiply this. Add them together, okay? And then equate it to this first digit. That's the logic. X1 times 1, that's x1, right? So plus y1 times 0, that's just I have x1 to be equals to 1 directly. So in this place now, I notice that I want to skip step. I don't want to rewrite everything again. So the matrix here now will be my x1 is trivially equal to 1. Okay. So what will be my y1? Let's multiply x1 times 0, 0. Y1 times 1 is y1 equal to, if I add 0 plus y1 equal to 0, I will have 0 as my y1. So my y1 is 0 in that case. All of this also, this one is x1, x2 equals to 0. Okay, this one is 0 plus y2 equals to 1, and that is y2 is equals to 1. Let's look for x3. X3 times 1 is x3 plus 0, that's the x3 equals to, this one is 0. If you do the same thing for the second part, x3 times 0 plus y3 times 1 equals to 0. So my y3 is also what? Is also 0. So what I have here now is just my A transpose. So what will be my, let me zoom out. So what is going to be my, which one can I clean now? I can clean this. You don't need it. Let me just take this off. Since my A transpose is equals to this matrix I have here, so what's now going to, let's check whether we will get the same result as what we have here. So my A now is actually equivalent to A transpose, the transpose of A transpose. So if I find the transpose of this one, what will I get? To find the transpose of this guy here, this A transpose, A is power of T. So the first column become my first row. The second column, which is 0, 1, 0, will become my what? Second row. You see, are they not the same? You see, they are equal to each other, so it worked. So we don't have any issue with this. I pray that we don't have any issue with this thing again. You know, this is what we are trying to prove the last time. Whereby we notice there is just a particular digit that makes it not to be equal to each other. So from here we will confirm whether this thing is valid or not. So I'm very, very sure it will be valid. Let's just do it one after the other. So I believe you all understand this. So that is for that. In that case, I can decide to, okay, we want to now find matrix. So we now find matrix B, okay, of phi with respect to the basis. Now we are given the basis here now. I notice that this one is an image of R2, right? While this one is an image of R3. That means whatever I have here, this image of R3 will fill up this place. And I will not use E1 instead. I will use E1 prime because this one represents E1 prime for a given basis. We use E1 prime. Remember that I have already explained that in the previous video, so I don't need to explain that again. While this one, for a given basis of this image R2, we always use it as F1 prime. This one is F2 prime. So this formula will now change entirely to E1 prime, E2 prime, E3 prime, F1 prime. And why am I using this one here first in this case? Because I have the image itself as R3 against R2. Okay, so I'm using this particular expression here, okay, because it has, this is actually the basis for R3. So you put the basis of R3 in this case because you already have XYZ, the image of R3 against R2. So while this F1, F2 will come into this place, this 4, 3 and 3, 2. Do you understand that logic? So that's what I want to do now. So I'm thinking of moving to the next page. Now let's check it out. We now have what are we going to have now? Let's check. So let me write out. I want to write out the, what do I need to write now? I need to write out this basis. 4332. So for a given basis, we always use it as E prime. E prime, we always take the two-dimensional vector space format, and we have it as 4, 3. Okay, we have it as 4, 3 and 3, 2. This is what was given, right? And we have our B prime, which is the given base for that linear mapping. So we have this one as 1 minus 1 0. Sorry, I'll put this in a bracket. I have the next one as 1 0 minus 1, and I have 1 1 1. Okay, I think that's correct. No issues. So this will represent our f1 prime, our f2 prime. This is our e1 prime. This is our e2 prime, and this is our e3 prime. Please always follow this my pattern. Follow the steps, the framework of this solution. That's the best thing. But okay, I'll try to do another example. So you feel like how will I know when to use this E prime as the two-dimensional vector spaces? What if it is 3 and 3? If this one is 3 and this one is also 3, how will you know which one to call your E prime? How will you know which one to call your B prime? So I'll also explain that too. But let's take it one after the other. In this case now I have phi of, okay, the main definition for the linear mapping. I want to write it out first. I have it as phi of xyz is equals to x comma y. This is the projection now, such that this thing looks like an image of R3 against what? R2. It maps from R3 to R2. So that means out of these two now, which one will I pick as my R3? That means I will go with this basis. This one has 3 image, this one has 2 image. So that means I will go ahead and write phi of E1 prime using that same theoretical framework that I just explained. E2 prime, while this one will be what? E3 prime, G standard logic. And that will be equal to, the main formula is now x, this one will be f1 prime, f2 prime. Remember to put x1 here, y1 here. This one is x2, this one is x3. This one remain the same all through towards the column, along the column. This one is y2, I have f2 prime. I have plus y3, f3 prime here. G standard logic. So now what is my x? I don't know, but I know my e1 prime. So now let's write our E1 prime. E1 prime is this first basis given to us here. And that's 1 minus 1, 0. Right? The second one, what's my E2 prime? 1, 0 minus 1. What's my E3 prime? 1, 1, 1. Right? So then we continue. So I quickly want to evaluate it once and for all. This x is 1, y is minus 1. Substitute it here. I will have 1 comma minus 1. Right? Here x is 1, y is 0. No z in this projection. So that means I only have 1 comma my y is 0, so I'll put 0 there. So here in this case I have x as 1, y is 1, z is 1, but there is no projection of z in the final result here. So I think I should have 1 comma 1 left in that case. So if I decide to write x1 here, and then you know what we actually have here. What's our f1 prime? Check it here. That's 4 comma 3. Then plus y1, that will be 3 and 2. So it remained the same all through, except aside from the x2, x3, and also aside from the y2, y3. So this is what we have. So how will you get the result for x1, y1? So you know what to do. So I believe in this case we need to solve this out. Can easily use the calculator. The simultaneous question will occur here. So let me just use this part here as my workings. So for this first row now, x1 times 4, that's 4x1. Then y1 plus y1 times 3, that's plus 3y1 is equals to this first digit 1. Second one, let's try the second one. X1 times 3, that's 3x1. Then plus 2 times y1, that's plus 2y1 is equals to this minus 1. So I notice we don't have the last one, we don't have anything like 0 to work with. Yes, we don't have any other one we don't have any other z, right? Since we are working with f3, except if the question asks us to purposely look for R2 against R3. In fact, it will not really work this way. So I believe this should just be the best way to solve it. Now, how can you solve this? To solve this now, we need to get this result. If you solve this simultaneously, what are you going to get? I believe you know how to solve simultaneous equation now. Just multiply this one by 2, coefficient of y1, coefficient of y1 here, minus, or use your calculator. It's advisable to use your calculator here because there's a chance of making mistake. Okay, so if I multiply this and this, I will have 8x1, 3y1 times 2, that is 6y1 equals to 2. So 3x1 times minus 3, that's minus 9x1. This times this minus 6y1 equals to 3. So if I add the two of them together, this will cancel this, 0. I will have minus x1 here. I will have 2. 2 is there. I have minus 1 in this case. Minus 1 times minus 3 minus 9, 8. I have minus x1 here. And I have 2 in this case. Okay. This is 2 plus. Now I'm adding the 2. 2 plus 3, that's 5. So x1 is minus 5. So if x1 is minus 5, you know what to do. I have 4 times minus 5 here. 4 times x1 is minus 5. Then plus 3y1 is equals to 1. So this is minus 5, right? Minus 5 times 4, that is minus 20. If I take minus 20 to the other side, sorry, this is 1, right? So since my x1 is minus 5, I should be able to sort out, okay, let's check. 4x1 plus 3y1 is equals to 1. Or should I use it from here? 8 times minus 5 is minus 40. Goes to the other side. That is minus, that's 40. That's 42. So I believe you can actually pick it from here. You can pick it from here. This is faster. It's still okay. But why is it that it's not working from here? 4 times minus 5, that is minus 20. It should work from here too. So when this goes like this, I have 1 plus 20, that's 21. So divide both side by 3. So my y is what? 7. So please just take your time and play around it. You will have your x1 to be minus 5. Okay. So you know what I want to do now. I just want to write out the matrix straight up. So I'll not waste time at all. My x1 is minus 5. I got my y1 as 7. Right? What will be my x2? Similarly, you do the same thing for x2. For x2, that will be 4x2. I'll just give you the final answer. I will not show the workings. 4x2 plus 3 times y2, that's 3y2, is equals to this one that is here. And the same thing, 3x2 plus 2y2 is equals to this 0. So then you solve it simultaneously. If you solve it simultaneously, your x2 will give us, our x2 will give us minus 2, while our y2 will give us 3. You can use the calculator to do that. You have minus 2 here, you will get this one as 3. And if you do the third one, you have 1, then you have your y3 as minus 1. So you can confirm. So whatever you have here now is your, they has to look for B. In your own mind, they has to look for B. But notice that that B is not this particular basis. I think we already used that B in this place. So that it will not look somehow. I've cleaned it. The basis represent E1, E2, E3. So why the B prime becomes this one? So now that you now start using the same letter for each representation, does not really make any sense. That's why I said you should change this question here. You'll have written it out. Okay, let this matrix B, let B represent A prime. That is the opposite, another matrix A, not B itself. So that means what I have here now is just the transpose, the transpose of A prime, right? That's the, or it's just okay. That's look for matrix B, right? You can write it as B. In your own mind, you know what you are doing. This B is just so that this B is not related to this B prime at all. You are not dealing with, you are not, this B is not the basis at all. That's what I'm trying to tell you. This one is the given basis, while the one that is just standard basis represents B. So the standard base of B does not represent, is not the same thing with this. Please take notes. That's why I want to use A prime. And if you don't want to use A prime, you can go ahead and leave it as B. But the result here is for B transpose. So how will you now get the matrix B that they ask us to look for? You now take B is equals to, when you take the transpose again, it will give you B. So take the transpose of this one. The first column will become my first row. The second column here will become my what? My second row. So we already have our answer for B in this case. So now the last part is to now show that that proof again. So I just hope it will work. So I believe it's going to work, sha. I believe it's going to work. So this is the last thing we need to prove. Where P and Q are transition matrix. We call it invertible matrix. P and Q are always invertible matrix also. We call it a transition matrix. So I already explained how to map I already explained the mapping for P and the mapping for Q. So that's what you also use here in this case. So we already have my B as this. So we now want to show that that matrix B is equals to the transposition P transpose multiplied by matrix A multiplied by matrix Q. So now recall that I said P is defined by this P. We always use it as the standard base to the given base. The given basis rather, the standard basis maps to the given basis, while that of Q is actually of this mapping that says that the given basis of this given basis B prime, I think this is for the image of R3. Yes, we always map to B. That was the um, proposition. That was what I proposed from our previous example. So when you have this now, what are we going to okay? Call that this might be right. This might be. So note that that B is not the same thing with this B that is there. That's just what I'm trying. You see, that's what I'm saying. This B is not the same thing as this one. That's my point. Okay. So that's why I always prefer that I should denote this one. Let's know that okay, this one is A prime. That is the second matrix A that we want to look for. While this one too also represents what we call it A prime. That's better. Let's use A prime. Okay, that's the best way to do that. So, how are you going to look for P? What is your E now? E is of this image R2, while this one is for the R3. So, what is my standard basis in terms of R2? That is just a 2 by 2 matrix of identity matrix, which is 1 0 0 1. Do you remember? And what is my E prime? That is the given basis, and the given basis it is stated there. I have it somewhere around. Okay, just hold on. Coming. So the E prime. Let's check for it. Where is it? These are E prime now. It's given to us the given basis. That's 4332. So that is 4. Before I even write 4, you know what to do. This is going to be our X. This will be 4, and this will be 3. 4, 3, 3, 2 or so plus. I have it as 3, 2. So remember that these are our x1, y1. These are our x2. This remain the same. These are our y2. So let's confirm before we start solving. Is it 4332? Exactly. So that's what we have. So to solve this thing now, you know what to do from here. You have to solve this simultaneously. That's 4x1. 4x1 equals to 1, right? That's 4x1 plus, 3y1 is equals to 1. Then I have 3x1 plus 2y1 is equals to 0. Now solve for x and y. Solve for x1 and y1. So multiply this one by 2, multiply this one by minus 3. That is, I still have the same thing as 8x then plus 6y1 equals to 1. Then I have this as minus 9x. We've done this one before. Minus 6y1 is equals to minus, that's 0. So if this cancel this, I will be left with minus x1 is equals to, add this together, I have 1. So my x1 is equals to minus 1. Stand by. Do the same thing for y1. So if you do the same thing for y1, that will be 3x1. Okay, that will be 3x1 plus 2y1 equals to 0. Then you solve it. Or maybe directly from here, we can easily get, instead of going to that straight, okay, we've done that already. We did 4x1 plus 3y1 equals to 1. We've done that already. So since our x1 is this, what is going to be our y1? Just come here and substitute. X1 is minus 1. That will be minus 4 here. Then plus 3y1 is equals to 1. If this goes like this, I have plus, right? I have plus 1 in that case. I think I'll surely get a fraction there. I'll surely get a fraction and that seems odd. That seems very, very odd. So what are we going to do in this case? Let's check this clearly again. If I add this together, I have minus x1 left. And this is actually equal to 1. That is what we actually have in that case. But looking at this now, it's not something that is really hard like that. So what if, okay, because I was hoping that we should get, I hope we can easily get 3 from here. Okay, let's check. X1 is equals to minus 1. Is that correct? So we need to verify if that is correct or not. We need to verify. I have 4 times x1, that's 4x1, then plus 3y1 equals to 1, right? And I also have 3x1 squared plus 2y1 equals to 0, right? So if I multiply 4x1 times 2, that's 8x1, then 3y1, that's 6, plus 2. That's what I'm trying to look for the error. Sorry for that. So now when I have this now, because I already seems this thing looks odd. If I take this to that side, I have 5. And getting a fraction does not really make any sense. That's why I was able to detect that this is wrong. So I made mistake somewhere. This is meant to be 2. So what I'm going to do next from here, let's correct that. So my x1 is minus 2. So if this is minus 2, that will minus 8. Then this becomes 9. Then I have my y as 3. So what I just want to let you know is that, okay, from here, if you look for your x1, you usually get minus 2. If you look for your y1, you get it as 3. If you do the same thing down here, look for x2 and y2, you can try that on your own. You will also get 3 and minus 4. Please verify that too. So what I have here is my P transpose, right? And that is what I'm looking for. Digital logic. And luckily for us, this thing here, even though you find the transpose again, you still get the same thing. I think that's a transition matrix. That's nice. Well, I'm not really sure, but let's just see. But if you find chances of this, we still get the same thing. But this is just our PT. We've gotten our PT, so we need to get Q. Now let's do something similar with that of Q also. Here is our Q. So Q is actually it actually has an image of R3, right? My B prime is the given basis. Yeah, right. Let's check the given basis for B. See it here. 1 minus 1 0, 1 minus 1 0. I have to clean this off. Now I have the second one as 1 0 minus 1, 1 0 minus 1, and I have the third one as 1 1 1, right? So this will be equivalent to this B itself is actually the given basis, not the B that they asked you to go and look for. No. This B now is to represent X open bracket. So now looking at this, what am I going to use? To mask back to B. And B is the standard basis in this image. That's 3 by 3 matrix, an identity matrix of 3 by 3. And that is 1 1 1 0 0 0 0 0 0. This is my E1, so I'll put it here, right? This is going to be my F1. The formula is F1, right? So sorry, we always use E1, E2, E3. Sorry for that. E1, E2, E3. So this one will be 1 0 0, then plus Y of, we take this one to 0 1 0. So that's not all, then Z comes in as 0 0 1. Why? Because the standard base represents B, and the standard basis is an image of R3 such that we have this identity matrix of 3 by 3. Then the first one goes for Y, the second one goes for, sorry, the first one goes for X, the second one goes for Y, and the third one goes for Z. So you know what to do here. X2, X3. Remember to put Y, X1, Y1, Z1 here. 1 0 0 0 1 0 0 0 1. Here I have 1 0 0 plus Y1 of 0 1 0 I think this should be easy. This should be very easy for us to get our values for x and y and z. Because looking at it, this one will become 0, this one will become 0. X1 plus y plus 0 equals to 1. So trivially, I can actually have my Q transpose that I'm looking for as I can see it clearly that this one is x times 1, x1, 0, 0 equals to 1. So I have my x1 as 1. If I want to find y now, the same thing goes to the second one. X1 times 0 is 0. I have y1, I have 0. So y1 is equals to this minus 1. And my z1 will give us this last 0. Do the same thing for this one. You still have your x1 to be equals to 1. You still have it as 0. You still have it as minus 1. All of this, if you do the same thing, you have it as 1, 1, 1. So this is my Q transpose. So what's now going to be my Q itself? I need Q. Q is equals to the transpose of Q transpose. And that is simply okay. Return all this first column becomes my first row, right? This second column becomes my second row, and this third column here becomes my third row. So in order for me not to waste our time, we want to look for our A prime. Remember that our A prime, recall that our A prime is minus 5 minus 2 1 minus 5 minus 2 1 7 3 minus 1. So this one we want to prove. Show that this left hand side is equals to, what's my PT? My PT is minus 2 3 3 minus 4. What's my matrix A? My matrix A is the first thing I did here. This shortcut here, or you show it using this. That's 100 0 10. That's 100 0 10 in that case. And then my Q itself is what I have as my 3 by 3 matrix. So now I want to use calculator to solve this, or do you still want us to solve it manually? So that will not, so I will not waste your time. Let me just go ahead and use calculator. When you use this to multiply this, you add it. The same thing. So it's going to take our time. So let me just use calculator for that. So for the first matrix here, I will input it on my calculator by pressing mode, and then you go for matrix. Then you go for shift and 4, which is dimension. You will see where you have DIN. Pick 2 by 2 matrix there, and then insert this minus 2 3 3 minus 4. Minus 2 3, then 3 minus 4 in that case. I have to input the value for this one too on calculator, or you solve it manually anyhow you want it. So for matrix B, I have it as, this is a 2 by 3 matrix, and I'll have it as 100. So I think I'll input that. So I've done that already. So I'll go ahead and input this also for the last part, which is 3 by 3. I have it as 1 1 1 minus 1. I have it as minus 1 0 1 0 minus 1 1. So let's just hope we have the same answer. So if you multiply this together, these three together, I want to use my calculator, and I believe I must. I hope you get this, yeah. So I will not have any issue again, unlike the previous video lesson. So I've already pressed matrix A on calculator now. Then I've put times. Then also I will need to input for matrix B. I've done that. I call this one my matrix B on calculator, not based on our solution. And I also multiply it. I multiply by this one. So I'm about to press the final answer. So luckily for me, I don't know if you can. There's no way I can actually display that. My calculator gave me minus 5, 2, minus 2 rather, 1, 7, 3, and minus 1. So it worked for this. So I still don't know the reason why it doesn't work for the previous one. But guys, don't worry. I'll make sure I work. I'll make sure maybe there's a particular mistake somewhere from that previous solution that makes, which makes this to be 0. I don't know what's actually wrong at this point, because that's the only value that makes it not to be equal. So I don't know where that mistake is coming from, but I'll make sure I look at it clearly again. So it actually works perfectly for this. It worked. So please, I need you guys to take note of these steps. This is the correct solution. So understand this step by step. That's why it took almost 1 hour to explain the basics from the first example. This is the second example. Okay, we also have more examples, Sha. We also have more examples. So let's try the one of 3 by 3. Like, you have been doing, the ones you have been doing so far is R3 against R2. What if you come across R5 against R2? So, understanding matter, it's still the same step, it will work. Just follow the same step, it will work. So, the example I want to take now is the one with R3 against R3. Yes, it's the one with R3 against R3. I think I have the example here, so let's check it out together. I have to be fast about this. Okay. See the question. It says, this be a linear map. Let this be a linear mapping of three-dimensional vector space to another three against three. Are you flowing? So let this be a linear mapping. That's the question. So we call this one example three, linear mapping, which is defined by, so let's check, it's defined by phi of xyz. Now if you have R3 here, this is showing R3. You must also have like three coordinates here too. And the coordinates are x, x plus y, and the last one here is 0. Now the question now says find, now let's start. The first one, find the matrix as usual now. The first one is always find matrix A. The second one is always find matrix A prime. See, there's nothing really special about this course. Now find matrix A and A prime. It is B they put here. Oh. They put B. Let me even follow the question. Let me put B. But in our mind, we know that we change this B to A prime. Okay. Find A and B respectively of what? Of the linear map phi with respect to the standard basis. Standard basis. The standard basis, I think they have already helped us here. They put E1, E2, E3. So you should know what that means. And the basis of 110, 011, 111. So this is what we are given. This is E1, E2, this is E3. Okay. Hence, as usual now, the last one. I think this is just find the matrix. Everything is together. Hence, they ask us to hence, show that there exists an invertible matrix Q such that B is equals to Q, yeah, it is Q inverse. I have this as Q, what is this? Okay. I have this as Q inverse. Oh, what's going on? I have this as Q inverse of A of Q. Now, I know sometimes saying Q inverse, what's happening? So they ask us to use Q inverse this time around. I think that other one is transition matrix P and Q. But yeah, in this case, okay, I have Q and I have Q inverse. That means I'm not looking for PT this time around. I will look for Q, then I'll also find the inverse. So that's what we need in this case. So how are you going to go about this? We want to look for matrix A respectively of phi with respect to the standard basis. Okay? And this they now give us another given basis. This is the given basis. If you want to look for A now, you use the standard basis. If you now want to look for the second one, you use this and this. So trivially, I can easily call this one my capital E because it already has the given basis of E1, E2, E3. I will just use capital E in that case. And this one will go for my what? Capital B in that case. So this one will not be my F1. Okay. I think this should be my F1, F2, and F3 in that case. This is what I will use. Okay, this one should be my F1. Let's see, because I don't even know which one to use. It's somehow confusing, but okay, this is somehow confusing. No problem. Let's just go ahead and solve. It's not something that is really hard. You can still show. You can still show this. Now let's check. You know, normally as usual, we need to find matrix A. Matrix A is I want to use the shortcut this time around. I'll just write out this projection here. I'll write it. It's in row form. I'll write it in column vector form, which is x plus y and 0. So my matrix for A now is for this first row. I can see x is 1, the quotient is 1, but there is no y because the major projection is xyz to this. It's projecting from this to this. So I have x only here. There is no y, there is no z. In this place, I have my x as 1, y is 1, but z is nowhere to be seen. Here, we do not have anything. That means x is 0, y is 0, z is also 0. So this is my matrix A that we're actually looking for solved. Now, how do you look for matrix B? To find matrix B now, you know that this B in our own mind simply represents A prime. That's the other matrix we are looking for. And to look for that, now the only issue we have now that we don't know which one we should call our, we don't know which one we should use um as our E1, E2 and like that. Do you understand that logic? So to look for matrix A prime now, which is matrix B, I will just advise you not to use this for the phi definition. You know, we always use E1, E2, E3. What I just noticed is that, trivially speaking, this goes to the right hand side. This one here goes to the right hand side. But before, is it the first one we used to use? The first one, in fact, initially, this first one used to be on the right hand side. Look at it. Let's check. You know, we are given this basis now. We are given this and this. This is the first one. This is the second one. The second one is the one that is represent E1 prime, E2 prime. But yeah, it's just like as if they want to convince you. So still, you can still follow that same procedure because I noticed that 4332, this 4332, when we wanted to look for matrix B, it was actually on the right hand side. Check 4332 used on the right hand side. Do you understand? While this represent, and the reason why I did that is because of the image of R3 against R2. But now that we now have R3, R3, so the three of them are balanced. So I don't know which one to use as. Maybe I should go ahead and use E1 here and then use this on the right hand side. You can also try, but for the sake of this tutorial video, to get the correct answer, I believe that if you use this here, because based on what we, this one is always on the right, this one is always on the left. So I need to use this one as my E1, E2, E3, and this one will be on the other side. Okay? Just as if they wanted to, they are just trying to tell you that this E1 is not just E1 representation in this space. This one is E1, E2, E3. While this one here is just like a standard basis that they wanted to use as 100, 001, sorry, 010, 001. So I'm starting with this on the left. I have this result here, right? And I also have the second one, and I also have the third one, right? So this will be equivalent to what? You know what to do from here. That will be X open bracket. Pick this E1. And my E1 now is, this is a 3 by 3 matrix, right? I can represent this is E1, E2. This is in row, so this is in column form, such that E1 is an identity matrix of 100, 010, 001. So my E1 now, E1 will be here. E1 now is 100, right? Then plus Y of E2, 010. Then I still have one more again, Z. So I think there is no space. I have to move. Okay, let me just clean the board here. Let me just go straight to the next one. So we have phi of, okay, call that. We have this as 110. We have 011. And finally, we have 111. So let's confirm. Is it the same thing? Yes, 111. And then here we should have x1 of the E1 itself, right? Plus y1 of the E2, which is 010, and E3, right? So this place we should have x2, I should have x3 here, right? Y2, y3, this remain the same. But this is just like, to me, I see it as a quantitative reasoning, as if you are just trying to fill up some gaps. But please, yeah, I still repeat, you need to understand this template very well. You need to understand how it works. So I noticed that I have 110. Let's check the, this is the definition, right? This is the projection. It projects to x, I think x plus y, and I have 0. So this is the projection here given to us. This is the linear mapping given to us, right? So then it's clearly saying that if I have phi of 110, x is 1, y is 1, z is 0. So substitute here. X is 1, y is 1. That's 1 plus 1. I have 2. This last one is already 0. So nowhere to, this one is already 0. Nowhere to put it. I repeat, x is 1, y is 1, sorry, x is 1, y is 1, z is 0. So if I substitute everything here, x is 1, y is 1, 1 plus 1, that's 2, z is just nothing there. I think this will remain fixed all through. This 0 will remain fixed. So this is our final. This thing is what we are putting here. We are just picking the values from the mapping of x to 1, y to 1, z to 0. So I have 0, 1, 1. So map it together. X is 0, y is 1, no z at all in this expression. And this will give us the final answer here. So my x is 0, my y is 1, x is 0. That's 0 plus 1, that's 1. And this is that's 0. And as for this one, 1, 1, 1. 1, 1, 1. That's 1, 2, 0. So I already have this result now. So when you get to this point, you know what to do. So that means I'll multiply this and this, this and this, this and this equal to 1 plus y1 plus y1 equals to 2. So I think this is direct. It's also direct. X1 plus 0 equals to 1. So my x1 is 1. Y1 plus 0 equals to 2. And this one is also equals to what? 0. And that's what we are going to have in that case. So if I use this as, hold on, yeah, that's what I'm supposed to use. And I feel this is what we are going to, is this what we are going to get? I think this is what we are going to get. Okay. But what I feel now is that if you do it this way, I don't think we are going to get the correct answer. I don't feel we are going to get the correct answer. What I feel now is that I noticed what I just feel now is that this standard basis now think is for hey, you need to that more in maths, you need to understand English very well. And there is we need to solve it respectively, okay? This to find the matrix A of this file with respect to the standard basis. This is standard basis given to us for matrix A. But you now see this matrix B now that we want to look for. We are only given just this. And if you are given this one only, just one only that you are given. So how will you now get the other one? They always give us two. They always give us two in that case. Like they will give us one base and the other base. Then so we can easily find our matrix, second matrix. So that means in this case now, this definition now will change. We are not going to use identity for this one. No. This standard basis This standard basis is for matrix A. That's standard basis of E1. While this one and so why this the given basis now is just one given to us, just one. In this case, whereby just one single basis is given, what are you going to do? That means you still use the same thing. 110. In this case, also you still use the same thing. 110. Take note. 011. That's what you will use. And this one will be 111. Please take note and you repeat everything all through. Okay? Please take note. If it's 3 by 3 and you are given just one, if one single basis is given, do you understand my point? So that's how it works. Please take note. Please take note of that. I need to take note of that. I repeat, this one here, with respect to the standard basis, this standard basis is for matrix A, and we already use. I not even sure the workings for this one, self. For the, I believe you know how to do that now. You know how to get matrix A without using this shortcut. It will work. Okay. And as for the second basis that they asked us to look for, we did not have two given bases. We only have just one given basis. And in that case, our advice is to repeat it. Since we don't have any other one to relate it to, it's coming back to itself. We are relating this out three back to out three. Out three against out three. So you are using this against it back. Don't use identity, please. So if I now want to solve this now, it will change. Oh. The value will change entirely. But this one is x1 plus 0 plus z1. That's x1 plus z1 is equals to 1. Then the second one will be x1 plus y1 plus z1 is equals to 2. Then 0 plus y1 plus z1 is equals to 0. Now solve it simultaneously. If you solve it simultaneously, that's three equations, three system of equations. If you solve it simultaneously, you will get 2 here. This one will give us 1, while this one will give us 2. So let me write that again. Or do you want me to show you that again? Okay, I'll just solve one and then you can actually try others here. This one is 1 times x1, that's x1, plus y1 times 0, that's 0, plus z1 times 1, that's z1, equals to this first result here. X1 times 1, x1, plus y1 times 1, that's y1, then plus z1 times 1, that's z1 is equals to 2. Then the last part, x1 times 0, 0, y1 times 1, y1, and z1 times 1, z1 is equals to 0. So you solve for x1, y1. So you can use a calculator for this. You can use a calculator for this one, so it will work. So when you solve for x1, y1, and z1, you will surely get 2. X1 will give you 2, y1 will give you 1, y this one will give you 2. If you do the same thing for this second row too, x1 plus 0 plus z1 equals to 0, you will have your answer as this. 1, you get 1, 1, 1 for everything. And this last part, you get minus 1, minus 1 for everything. So whatever you get here now is my, is no, I'm looking for matrix B. It's my B transpose. In your own mind, you're doing that it is A prime, the other result for matrix A. So now look for matrix B in that question. That's the transpose of, take the transpose again. So this column becomes my row, this second column becomes my row, and this third column becomes my third row. So this is going to be, sorry, if I solve this, take note. Okay, I'm very sorry for that. This is the final answer for B, if I'm not mistaken, because the solution I have here, the workings I actually did there, I actually picked the wrong values. So if I solve for x1, y1, and z1, try it on your calculator, you notice that the result that you will get will give you 2, 1, minus 1. Please take note. While this one, while the ones here will surely give you 1, 1, minus 1. That is z1 will give you minus 1. And this last part here will give us something like 2, 1, minus 1. This is what you're going to have. So that when you now find the transpose, when you now, this is our B transpose now, such that such that this is now going to be our, these are B transpose, right? So if I now take the transpose of this one again, now my final answer for matrix B will now be 2, 1. This first column become my first row, second column become my second row, and this third column becomes my third row. Please take note of that. Please take note of that. So what other question they asked? They said, question says, where is it safe? I think I'll skip that. This is it. The question says, hence, there exists an invertible matrix of Q such that we want to show that B is equals to Q inverse A of Q. So how will you look for Q when we don't have, okay, when we don't have two bases given? How will I look for Q? Normally, to look for Q, we are all familiar with that. We always use our available base, right? I think the B prime, the given base, equals to the standard basis, right? So that's what we are going to do. And I think that should give us, let me do that here. To look for Q now, that is equivalent to the given base, we always map to the standard basis. So the given basis now, this is actually equivalent to the given basis, if you can recall, we have it as 110. Go and check it out. I'll show it again. This is given, this is the base they give us. This is what I was given. Okay, then equal to. Now we can't look for P. Do you know the reason why? But P is not given because we don't have, we always have 4, 3. That previous example was 4, 3, 3, 2. That's for the first given base. You also have another given base. So we always use this one to find the P. We always use the other one to find it. That's why P was not in that proof, in that right hand side of that proof. So now if you have this, what's my standard basis? That's X. I'll put standard basis is now the 3 by 3 matrix now, right? 0, 1, 0, and then that's 0, 0, 1, right? This B now is an identity matrix of E1, E2, E3, and that's a 3 by 3 matrix, if I'm not mistaken. So this is your E1, E1 is here, E2 is here, and E3 is here. That's my standard basis. So this one will be my X1, Y1, Z1, X2, X3. Do you standard logic? This Y2, Y3. So that's how it works. What is this? What am I writing here? This is 1, comma, this is 0. So I have 0, 1, 0. This is Z2, this is Z3, this is Z1, this is Z3. right? So now if I want to look for x1, whatever I get here now is my Q transpose, if I'm not mistaken. So if I look for Q transpose now, that means if I look for this is direct. X1 times 1 is x1, okay? X1 0 0. So x1 is equals to 1. Y12 will give us 1. This one times 0 0 0. Z1 is equals to 0. So I will have this result back. Trivially, I will have it back. Similarly, that's what you have been doing since all this one. So what's now going to be my Q itself? Q is just the transpose of the given basis. I think that's just the shortcut. Let's just put it that way. Q is just the transpose of the given basis. So if I find the transpose of this one, now that should be this becomes my new row. This becomes this second column becomes my second row. This third column becomes my third row. So what I need now is Q inverse. Look at what we want to prove. We want to show that B, the matrix B that we got as this is equivalent to when we have Q inverse times A times Q. That's the question. What's my Q inverse? How do you find the inverse of this kind of matrix? It's not something that is easy. 1 over, look for the determinant of this, then times the cofactor. So it is not going to be easy for you to solve this kind of question except to use a calculator. Please, if there's a way to use calculator. I have YouTube video on that. How to find the inverse of this. How to find the inverse of this matrix. I think there's a short, is there a shortcut for that? No, I can only find the determinant easily. To find determinant, I have a shortcut to find determinant. Let me show you. Using Saros rule. I want to use Saros rule to find this determinant, this one here. But to look for the adjoint, it's not something that is really fast to do. But I can easily help you with the determinant here, this down part. If you want to find put plus minus plus, it will take your time now. I don't do it that way. Just repeat this first and second column here. I want to use another color. Sorry for that. I want to use color. Let me use this. So what I want to do now is that, okay, this is the matrix and I want to find the determinant. Just repeat this first colon and the second colon at the extreme. Okay, I repeated it right. 0, 1, 1. Done. Close the bracket. And let me pick another color. Now, where is the center of this first row? The center value. The central value is this, right? Now let's multiply the right to left diagonal like this. Multiply this. What will you get? 1 times 1 is 1 times 1 times 1 times 0, that's 0. You fall it downward. You don't have to multiply the upper part. You come downward. Okay. Now the down part is you multiply this next one like this. What would that give us? 1. Then I will multiply this one again. That will also give us what? 1. Right? So then this for the right to left diagonal. Now from left to right diagonal, from this same point, I'll multiply left to right. This left to right. 1 times 1 is 1. What of this? Multiply this one. I will also have 0. Multiply this one. And I'll have it as 1. So I will now add all these things together. If I add this and this, I have 2. 0 plus 1 plus 1 is 2. Okay. If I add this one together, 1 plus 1, I also have 2. Then this minus this. And that becomes infinite. So is it possible to find the inverse of this matrix? No, that is not. I think it's no inverse that's supposed to look for. I'm not sure it is inverse because this matrix is actually invertible. An invertible matrix does not have an inverse. You won't be able to find it because the down part will always give you 0. But 2 minus 2, I will subtract this. The determinant of this guy here is 0. And 1 over 0 is infinite. It's infinite, so it does not work. So I'm very sure there's an issue with that question. It's not inverse. That's not what that's supposed to prove. It's still the same. It's still following the same process as P. But we are not using P in this case. We are using P transpose. Please take note. It's Q transpose. Please take note. It's Q transpose. Sorry for that. It's Q transpose. So that means I have to correct this now. I have to seriously correct this. Not this was. No, we are not looking for inverse. In the question I have here, the person writes inverse question. I'm very, very sure it is not inverse. It's meant to be transpose. That's what that's supposed to prove. So since I'm looking for the Q transpose, now I want to clarify this now. What I have here now is the Q. What I have here in this result here is the Q transpose. If I look for x1, x1 is 1. My y1 My y1 is also 1, right? My y1 is also 1. My z1 is 0. And this one is 0, 1, 1, 1, 1, 1. So I'm trying to look for a way to do this. And then the q now, the q we are going to have now is what we are going to have as q now is actually our, okay, our q now will become, this becomes our row 101, 111. This becomes our new third row. So I already have my q. I want to show that q, I don't know what the guy, I think it was, he wrote inverse. This is how it was written. I already have q, I have a, so I have issue with this one now. I don't know that it is, if it is transpose now. I already have the result. So if I multiply this with matrix A and this, will I get that result? It's not, I'm not sure. Is that going to be possible? Will I get matrix B back? That's the question. So looking at this now, is it possible for us to look for the inverse of Q? Okay, we went to go and look for the inverse of the transpose. It will not have an answer, but this should exist. You know, you are looking for Q inverse. The stuff, what I did the other time was the inverse of Q transpose also. Okay, no wahala. So this is our Q now. Now let's find Q inverse. So I still want to use that Saros rule. I have 110, 011, 111. So then I will use, you know what I'm going to do now? I will repeat the first and second column. 110, 011. Then I'll look for the middle value here. And then multiply this and this together. Left to right, I have 0. This one, I have 1. This one, I have 0. If I multiply the left to right, I have 1. This one, I have 0. This one, I have 1. So I have 1 plus 1 here, that's 2. I have 1 here. So the left to right diagonal, the formula is left to right diagonal minus right to left diagonal. That's 2 minus 1. You sum all these ones together, this one will result to 2. If you sum this one together, it gives us 1. So you do 2 minus 1, and that is 1. So the Q inverse now by formula is 1 over determinant of Q, abi, then times the adjoint of Q. And that will be 1 over determinant of Q is 2. I got it as 2 minus 1, right? And that is 1. Then the result I'll just have is just that. Just find the adjoint of this. And how will you find the adjoint of this? It's another thing entirely. Is you really take your time. But calculator can do this for us. It can. Calculator will give us the straight answer. So if you look for the adjoint of this one, no, the formula is adjoint. If you look for the adjoint, it give us 0, 1 minus 1, 0, 1 minus 1, minus 1, 1, 0, then 1 minus 1, 0. There's a way we used to find adjoint too, because you have to pick this one first and then cut it off. 1 multiply this, 1 minus 1, that's 0. 0 times 1, that becomes my adjoint, 0. If I want to pick this now, I'll cut it off. 1 times 1, 1 minus 1 times 0 is 0. So 1 minus 0, that is 1. That's how we got this one. I'll pick this one next. Cut this off, cut this off. I have this matrix left. Find the determinant and write the answer. 1 times 1 is 1 minus 0. And I believe that this is plus, minus, plus. So this is how it's going to work. This is the result you're going to have. So I noticed that my Q is, what did I get as Q? Let me write it out again. 101. My Q is 101, 111, 011. My Q inverse. You can just use your calculator straight up. If you use your calculator, you will get 01 minus 1 minus 110, 1 minus 1 1. This is what you will get as your inverse. So now we now want to check that is B equals to Q inverse times A times Q. Let's confirm. This 01 minus 1, this minus 110, and this 1 minus 11 times our A. Let's check what our A is. Our matrix A is 100, 110, 100, 110, 100, 110, 000. If you multiply it with this matrix Q that is here, 101, you notice that your final answer will give us, if you solve this on calculator, this is what you get. Use your calculator to multiply this matrix together. You have 212, 1, 1, 1, minus 1, minus 1, minus 1. So is this thing equivalent to what we got as our B? Let's check. 2, 1, 2, 1, 1, 1, minus 1 or 2. 2, 1, 2. So it's correct. So that means this ends the proof. So that's how it works, please. I need you to take note of this explanation. So that's how it works. I think that's all on that. But what if you come across rank of matrix? That's the next thing we need to consider. How do you find rank of matrix? And how to find determine the minimal polynomial of a matrix. So all those things are what we still need to consider. We still have a lot. And then finally, we still have to consider the bilinear form. There's a proof under it, bilinear form. But anyways, let's just stop here for now. So that's how linear mapping works. We also have like two more examples of linear mapping. Then we can go ahead and take one more topic, and that ends the course for now. So thanks for watching.